Hey everyone, welcome back to the EdgeVerse Techcast, your go-to show for NXP's software, tools, and enablement for our processors and microcontrollers. As always, I'm one of your co-hosts, Kyle Dando.
And hi, listeners. I'm your other co-host, Bridgette Stone. In today's episode, we're thrilled to explore the new eIQ Time Series Studio with our guest, Ted Kao. Welcome to the show, Ted.
Hey, thanks, Kyle. Thanks, Bridgette. Thanks for having me on the show. So I'm the AI Product Marketing Director at NXP, where I focus on making AI and machine learning more accessible on microcontrollers. I lead the definition and marketing of our eIQ software, as well as a Neutron NPU IP, both designed to simplify AI and ML development while delivering high performance and low power consumptions.
Well, thanks for being on today, Ted. I'm going to kick us off and we're going to jump right in. So, what makes running AI on the edge such a game changer, and why has time series based AI in particular been so challenging for developers until now?
So yeah, we have all seen how AI is transforming our lives in the past couple of years. And at NXP, we see tremendous opportunity to bring AI from the cloud to our edge processors. And this enables fast and accurate decision-making right at the edge where data is generated. This also brings benefit like lower latency, reduced power consumption, and improved data privacy by not always sending the data to the cloud. So while we have parallel development for computer vision, voice, large language model, generative AI, those exciting stuff, time series AI is equally powerful, especially for microcontrollers. And that's why I'm here, and I'm excited to share today. So what's time series AI, as most people would ask? So think about tasks like anomaly detections, classifications, regressions, and how people leverage sensor data to make intelligent decisions and predictions in dynamic real-world environment. However, what most people don't recognize is building AI models with time series data is not easy based on the years of experience we have had with our customers, and usually takes deep expertise in sensors, data, machine learning knowledge all together to make it easy for the developers. That's why we developed the eIQ Time Series Studio, and that's included as part of our broader eIQ toolkit.
Great introduction and overview. Thanks, Ted. Are you able to go into additional detail on the eIQ Time Series Studio tool, and how does it make this specialized AI accessible to developers?
Sure, Bridget, I'm happy to do that. So Time Series Studio is an end-to-end development tool that streamlines the machine learning development workflow from data curation, model training, optimization, emulation, all the way to deployment on NXP devices, and all in one place. While it's important to provide an end-to-end workflow, what makes Time Series Studio super useful is the integrated automatic machine learning, or short for AutoML, as that takes part of the heavy lifting by intelligently generating and tuning models. So you don't need to be an ML expert to get great results. And it dramatically speeds up the development and lowers the barrier to entry for anyone looking to build AI at the edge. And the best part, it's completely free. Our goal is really to make edge AI more accessible and remove as many roadblocks as possible for developers everywhere.
All right, Ted. Anytime you say completely free, that perks up our listeners' ears. I'm a pretty frugal guy, and when I have two options, I always tend to appreciate and evaluate first the free tool. I'm sure our customers are thinking the same thing. I've had some experience looking into the Edge AI tools, and I think it's really rare to see all the features that you've talked about in a zero-cost tool. They may get something to evaluate the AI, but it sounds like what you're describing is the developers get all the levels and they can jump in and evaluate all the advantages of our tools. So with that, why don't we dive in even a little bit deeper? You introduced the topic of AutoML, which is at the heart of NXP's Time Series Studio. Can you walk us through exactly how AutoML transforms and improves that developer experience?
Sure. I'm happy to do that. So again, AutoML or automatic machine learning really changed the game for building machine learning models. For developers, as you may know, it takes a lot of trial and error in mainly testing different signal processing techniques or model architecture in the past. And it was really slow, tedious. It requires like pretty deep machine learning expertise. And now with AutoML or automatic machine learning integrated, that process become much, much easier. It automatically explores and fine-tunes a wide range of model options and signal processing to find the best balance of accuracy, performance, memory, efficiency, all without the need to write in a single line of code.
Okay, so this AutoML is truly the lab assistant that all these AI developers have been waiting for. They finally have someone or something to help them out with all that tedious analysis you talked about. All those available models, I'm sure they come about all the time. This AutoML will help steer them in the right direction and help them evaluate the trade-offs.
Yes, yes. So I mean, based on our working experience with even like experienced machine learning developers, they are often surprised about how much time and how easy it is to use time series studio. And what used to take weeks for them to develop a model now can be done in hours. And you still get a visibility into how each model is built and how it performs. It's again super helpful for embedded developers working with again microcontrollers with tight memory and compute budgets.
Wow. So even seasoned ML pros are saving weeks here. Absolutely incredible. I bet that frees them to focus on fine tuning and real innovation rather than tedious trial and error. So, speaking of innovation, Ted, tell us more about the variety of sensor inputs you can work with.
Sure, sure. So yeah, this tool is built to support a wide range of sensors. Again, motion, temperature, vibration, pressure, sound, just to name a few. And it even supports voltage and current that may not require extra hardware. And for some of our customers, that translates into no additional cost. And it also supports sensor fusion, combining multiple inputs for more advanced multimodal applications. And there are, again, three main use cases, as I mentioned earlier: anomaly detection, classification, and regression. And they apply across industries like industrial automation, medical, smart home, and automotive.
That's really a great overview of applications. Are you able to zoom into some real world use cases for us?
Of course, of course. So let me just provide a couple examples. Take manufacturing, the first one. As factories become more automated and robotic production lines are integrated, catching abnormal machine behavior early is actually really critical. And sensors today can play a key role to not only prevent costly breakdowns, but also to monitor the health and lifespan of equipment over time. So that's one. And at home, think about appliances like washer dryers and refrigerators. Sometimes will make strange noises or vibrations. Those are often early signs of trouble. With AI built in, those devices could detect issues early and alert you before things get worse. And one other example that, again, come to mind is like somebody living in California where wildfires are a constant threat. Arc fault detection is one of the use cases that may seem niche to some people, but we take it seriously. If AI can detect or even predict electrical faults that could spark fire, it has a great potential to play a real role in preventing or minimizing natural disasters.
Yeah, Ted, I love that power arc detection example. Also being from California, those were tragic incidents that if our machines and our products were a little bit more intelligent, they could possibly save lives and save a lot of money. It's amazing to see all this edge AI directly contributing to these new, safe, and reliable systems being built. The ability for new products that we've been discussing to identify things, these anomalies where the humans used to not be able to monitor based on it was just unrealistic or in some cases even impossible to monitor the system. I think this is a huge improvement. And that right there, that's a headline for any AI ML consideration. So now let's shift gears a little bit and look at how the Time Series Studio tackles this messy real-world data. Ted, can you share more on how the tool helps developers curate this valuable input data from all their varying applications?
Yeah, that's a great question. And indeed, it's really important to have a solid data curation tool when working with time series AI and with sensor data. So real world sensor data can be messy, especially in real world environment. And developers often have to deal with different sampling rate, noise, and inconsistencies when they work with different and multiple sensors. And Time Series Studio makes it easy by letting developers log, visualize, label, clean, and align the data all in one place. And that saves a ton of time and frustrations, no matter if someone is working with single or multiple data streams.
Okay, but what can customers do to expedite? I know getting data sets is one of the most time-consuming parts of building a successful model. So how can they import data sets into the Time Series Studio? Does the tool support different ways of doing that?
Yeah, obviously you can log and capture your own data, or you can also import the data from external sources. And by the way, aside from just importing and capturing the data, we also incorporate what we call data intelligence. And that's a utility that can be used to spot like data imbalance, redundant channels, and optimize sampling settings. All those utility really helps the developers make informed decisions on their data before processing and before the model training even begins.
Those utilities must be a developer's best friend. No more surprise data glitches, and being able to spot noise and trends at a glance will save hours of head scratching and accelerate root cause analysis. Now, how does all this translate into seamless deployment with the NXP hardware? Once a model is ready, how do developers deploy it?
Yeah, that's another great question. So deploying AI can also be difficult without the right tool. So with eIQ Time Series Studio, models can now be easily deployed to NXP microcontrollers or application processors with Cortex-M and Cortex-A cores. If the hardware includes an NPU or neural processor, such as the eIQ Neutron, complex model can also get accelerated for better performance. And once the developer selects their preferred model, the tool will compile and generate a custom library that's fully compatible with GCC, Kale, IAR, CodeWarrior, this type of compiler and environment. And from there, it's just two simple API calls, one to initialize the model and the other one to run the inference. That's all it takes.
Only two API calls. Well, that's pretty easy to do. All right, now that you've simplified the deployment to just the initialization and the inference calls, that removes a ton of the complexity that a lot of developers have in their AI projects. So it looks like developers can get models up and running in no time. Before we wrap, Bridgette, why don't you recap the highlights that you've heard from today's episode?
We've really covered a lot today. We unpacked what eIQ Time Series Studio is, saw how AutoML accelerates model building, explored sensor inputs and use cases. We dove into data curation and learned how to deploy models on NXP devices. Thanks so much for being here with us today, Ted.
Yeah, thanks so much for having me. It's a pleasure to join the Techcast and sharing some of the exciting work we are doing with enabling AI ML at the edge. And for listeners who are curious to explore about the eIQ Time Series Studio, you can download the full eIQ toolkit at nxp.com/eIQ. And we can't wait to see what you will be building. And if you have any feedback or suggestions or how we can better support your development journey, please don't hesitate to reach out.
All right. Well, again, thanks, Ted. What a great episode. I learned a ton about the Time Series Studio. I did notice, Ted, in our prior episodes, we always talk about our application code hub, and there is a Time Series Studio example in there. I'll drop that in the episode link, as well as the direct access to the eIQ toolkit so that the listeners can get to that quickly.
Yep, that would be awesome.
All right. Well, as always, if you enjoyed this conversation, please like and subscribe. Make sure to tell all of your friends that you learned something new on the EdgeVerse Techcast. And hit that notification bell so that you never miss a time when Bridgette and Kyle have something new to share.
And we'd love to hear your feedback or topic requests, so please reach out on social or drop us a line.
And until next time, keep innovating at the edge, and we'll catch you on the next EdgeVerse Techcast.